space explorers, and welcome back to the channel where we unravel the grandest mysteries of the universe. Have you ever looked up at the night sky and wondered where it all came from? Not just the stars and planets, but everything. Time itself. Today, we're embarking on the ultimate journey back in time, all the way to the very beginning. We're going to witness the moment our universe burst into existence. The Big Bang. So, what exactly was the Big Bang? It's a common misconception to picture it as a massive explosion in an empty space, like a bomb going off. But that's not quite right. There was no space for it to explode in asterisk. The Big Bang was the beginning of space, time, and all the matter and energy we see today. It was an event that happened everywhere, all at once. Let's rewind the cosmic clock. Imagine compressing our entire vast, sprawling universe, every galaxy, every star, every single atom down into a point smaller than a proton, yet containing everything. This infinitesimally small, unimaginably hot, and incredibly dense state is what scientists call a singularity. We don't have the physics to fully describe what a singularity is, but it's the starting line for our known universe. The moment before this, we simply don't know. Time, as we understand it, hadn't started yet. Then, approximately 13.8 billion years ago, it happened. From this singularity, the universe began to expand. This wasn't an explosion outward, but rather the expansion of space itself. In the first fraction of a second, known as inflation, the universe expanded exponentially, growing from subatomic size to larger than a grapefruit almost instantaneously. This incredible burst of growth is what smoothed out the universe, giving it the relatively uniform structure we observe today. In these first few moments, the universe was a chaotic, searingly hot soup of fundamental particles. It was too hot for atoms to form, let alone stars or galaxies. Protons, neutrons, and electrons zipped around in a plasma. 1 billion degrees hot. It was a cosmic furnace of pure potential. As the universe continued to expand, it also began to cool. This cooling was the key. Think of it like steam condensing into water. The universe was cooling down enough for things to start sticking together. About 3 minutes after the Big Bang, the temperature had dropped enough for the first atomic nuclei to form. Protons and neutrons fused together to create the nuclei of the simplest elements, mostly hydrogen and helium, with a tiny bit of lithium. For the next 380,000 years, the universe was still a foggy, opaque place. Light particles, or photons, were constantly scattering off free-flying electrons, unable to travel very far. The cosmos was like a dense, glowing fog. Then came a pivotal moment. The universe cooled to about 3,000 degrees Celsius, cool enough for electrons to be captured by the hydrogen and helium nuclei, forming the first stable, neutral atoms. Suddenly, the fog cleared. With the electrons now bound in atoms, photons were free to travel unimpeded across space for the very first time. This first light is something we can still see today. It's called the cosmic microwave background radiation, or CMB. When we look at the CMB, we are literally seeing the afterglow of the Big Bang, a baby picture of our universe when it was just 380,000 years old. It's the oldest light in existence. For the next few 100 million years, the universe entered a period known as the Cosmic Dark Ages. The first light had been released, but there were no stars yet to illuminate the cosmos. It was a vast, dark expanse of hydrogen and helium gas. But gravity, the silent architect of the universe, was already at work. In regions that were ever so slightly denser, gravity began to pull more and more matter together. These tiny fluctuations in density, which we can actually see as temperature variations in the cosmic microwave background, were the seeds of everything to come. Slowly but surely, over millions of years, these clouds of gas collapsed under their own gravity. They grew denser and hotter until, finally, the pressure and temperature at their cores became so intense that nuclear fusion ignited. The first stars were born, blazing to life and ending the cosmic darkness. These first-generation stars were colossal, hundreds of times more massive than our sun, and they burned through their fuel incredibly quickly, living for only a few million years. When these giant stars reached the end of their lives, they exploded in spectacular supernovas. These explosions were not just endings. They were powerful new beginnings. Inside their fiery cores and during these explosive deaths, heavier elements were forged: carbon, oxygen, iron, all the elements essential for life as we know it. These elements were then scattered across space, enriching the surrounding gas clouds. This cosmic recycling allowed the next generation of stars, and the planets that formed around them, to be made of a much richer and more complex mix of materials. From this enriched stardust, our own solar system began to form about 4.6 billion years ago. A cloud of gas and dust collapsed. Our sun ignited at its center, and from the swirling disk of material left over, Earth and the other planets were born. Every element in your body, other than the primordial hydrogen, was forged in the heart of a long-dead star. As the great astronomer Carl Sagan famously said, "We are made of star stuff." So, from a point of infinite density to a universe teeming with galaxies, stars, and potentially life, the story of the Big Bang is our story. It's the story of how time began, how space expanded, and how the fundamental ingredients for our existence were created. It's a journey of 13.8 billion years that has led to this very moment, to you watching this video. The universe is still expanding today, and its grand cosmic story is still being written. What a mind-bending journey. It really puts everything into perspective, doesn't it? If you found this trip back to the dawn of time as fascinating as I did, please hit that like button. It really helps the channel. And for more deep dives into the cosmos, make sure you subscribe and ring that notification bell so you don't miss our next adventure. Thank you so much for watching. And as always, keep looking up.